Okay, so over the last week we have been graphing parabolas, right? Quadratic equations. And we've looked at translations. And we're going to look at that again, but in a little more detail today. So last week we talked about, remember we did the Desmos activity? And you just graphed x squared plus k, right? My k is what value of the vertex? It's the y value. And how does k move your graph from the original parent function? What does the k do? How does it move it from that spot? It moves it up or down. Right? If you read the rest of that sentence, it also tells you it moves it vertically up or down. But k is going to move it up and down. We also graphed y equals x minus h squared. H is the x value of your vertex, and that moves your graph left and right. What else is special about h that we need to remember? Take the opposite sign. Okay, it's always opposite of what you see there. All that information we already know, right? We know that already. Okay. You also should know vertex form with h and k already in it. And we've dealt with key features. So the only thing we're really adding today is creating a table of values and graphing. Okay, but you look at this. Yes, but we haven't really graphed an equation that has a shift left and right and up and down. We've just done one of the shifts. Okay, so you've taken vertex form and you've identified all the key features. You've seen vertex form, right? I show it to you first and do all the key features first. So the graphing part really is just a table of values. Are we okay with that? Okay. I do want to make sure and just kind of follow up. What determines the orientation of the graph? The a value. So if a is positive, what happens? It opens up. And if a is negative, it opens down. Again, stuff you still know, right? A value also determines the shape of the graph, whether it's skinny or wide, or compression or stretch. Either words are fine with me. And then you'll see line of symmetry. It's also known as the axis of symmetry. Just know that they're both the same thing. Okay, and that's a vertical line that goes through what? The vertex. Okay, it's a vertical line that goes through the vertex. All right, so before we graph this first one, let's identify some of these key features, which we just did in our warm-up. So what is the orientation of this first equation? Why do I know it's up? A is a positive 1. There is a positive 1 out in front of those parentheses. Now, do I have a compression or stretch, or is there no change based on the parent function? No change because A is equal to 1, right? Now, before I look at how it translates, what is my vertex going to be? Okay, so H is opposite, K is the same. Now, that tells me which direction am I moving for the X direction, left or right? Right. I'm going to move right 3 units and up 1 unit. Okay. This is not going to be part of your key features, but it will help you when you graph to kind of see that your graph's in the right spot. And then what's my axis of symmetry?
X equals 3.
X equals 3. Don't forget X equals. If you don't put X equals, I will mark it wrong because it is a line, not just a number. Now, when we're creating our table of values, we use our vertex as our middle point. Okay? And then we need to find 2 X values below 3 and above 3. So what are the 2 X values below 3? 2 and 1, and above 3? 4 and 5. And as long as you pick the appropriate X values, everything's going to be symmetrical.
Wait, where do you like 5, 4, 3, 2, 1?
I like to do the smaller numbers first and then the larger numbers, but it doesn't matter. Because normally we go from least to greatest, X value wise, right?
I usually do.
If you write it 5, 4, 3, 2, 1, it's the same as 1, 2, 3, 4, 5. Okay? Your vertex needs to be in the middle, and you need 2 above and 2 below. Okay? So let's plug in the easiest number. I'm going to plug in 1. So 1 minus 3, negative 2. Negative 2 squared,
4.
4 plus 1, 5. So because it's symmetrical, it should also be 5 down here. Right? If you don't believe me, you can plug it in, but I promise that it is. You believe me? Okay, good. If I plug in 2, 2 minus 3,
A negative 1.
negative 1 squared,
1.
1, and then 1 plus 1,
2.
2. So before I even graph, I know my graph is going to be shifted over 3 up 1. So my vertex is going to be over here somewhere. It's going to face up. It's going to look like the parent function width-wise, like it's not wider or skinnier. If it doesn't have those 3 things, you did something wrong. And it probably happened in your table of values.
Wait, I have a question.
Yep.
So how is it going to like switch if they have the same vertex as the?
What do you mean?
Like, I guess I'm confused. I guess I see.
Okay, so let's graph these points and then maybe we can answer that question. So 1, 5 goes here, 2, 2, 3, 1. Make sure you have the arrows on your graph. Make sure it's not a complete V and there's a curve there. So in comparison to the parent function, it just shifted. All the points shifted over. Because it's still the same width, it still faces up, none of that changed, it's just a shift. Does graphing it help answer the question? Okay. Are we okay with that? Okay, so let's do the next one together. What's the orientation? Up, because A still equals 1, right? What's the shape? No change. Because A is equal to 1.
Oh, okay.
So if A is less than 1, what happens?
Then it's like, it's compression.
It's a stretch. It gets wider. If it's greater than 1, it's a compression and it's skinnier. Spanx. Yes. See? Next year they're gonna talk about compressions and stretches and you're gonna be like Spanx and they're gonna think you're crazy. It's okay.
You already think I'm crazy, so
All right, fair enough.
really.
What's the vertex?
2, 4.
Okay.
That's like a robot.
Sound like
You just sound like a robot.
two.
Okay, which means it translates which way, left or right?
Right.
Right, 2, and up 4. And my axis of symmetry?
X equals 2.
X equals 2. Okay, my center point is 2, 4. What are 2 values below 2? 1 and 0, and 2 above?
She's excited.
Very excited. I like it. I think it's Brooke. Brooke's excited. All right, so if I plug in 0, because I'm going to plug in the easier numbers. 0 minus 2, negative 2. Negative 2 squared is 4. 4 plus 4 is 8. And again, it's symmetrical if I did my math right. If I plug in 1, 1 minus 2 is negative 1. Negative 1 squared is 1. Plus 4 is 5. Now again, it should be shifted to the right and up, so my vertex is going to be over here. It should face up and it should be a normal graph. If it's not those 3 things, you did it wrong. Okay, so 0, 8, 1, 5, 2, 4, dun, dun, dun. We're going to do this last one together, and then you get to do the 3 on the back with your team. If you can identify key features, which we did in our warm-up, and you can graph, that's your quiz tomorrow. Okay? So hopefully not too bad. All right, what's the orientation on number 3? Down. Because A is equal to what? -1. What's the shape?
A stretch. No change. Never mind. Just kidding.
It's no change because A is 1. That number is still 1.
So wait. Did you have a negative? Would you like?
You don't look at the negative.
The positives and negatives you only look at when you're dealing with the orientation. Other than that, you can ignore the negative and just look at the number for the value of A.
So would you distribute a negative when you multiply?
Yes, you'll have to still distribute that negative when you multiply. But when it comes to the shape, just look at the number, not the sign. So if it was a -2, 2 would make it greater than 1, right? Which means it's a compression, so it would get skinnier. Because the negative would only tell me that it faces down. Okay? My vertex is -1, -2, which means I go to the left 1 and down 2. And my axis of symmetry?
Is x equals -1.
Okay? So -1, -2 is my center point. What are 2 points or 2 values below -1?
0 and 1.
-2
-2 and -3, and then above would be 0 and 1. Okay, I don't really want to deal with negatives, so I'm going to plug in 0 and 1. Are you okay with that?
Yeah.
So 0 plus 1 is 1. 1 squared is 1, but I have this negative. So it's really a -1. Everyone okay with that?
Yeah.
-1 minus 2.
-3.
Do you see how I got that? Okay. Oh, I wrote that on the wrong one. I plugged in 0 just now, didn't I? You never what? Oh, this is the best whiteout. Okay, if I plug in 1.
You still get. You still.
Oh. I fixed it on one but not the other.
Yeah.
I'm a mess. It's okay. Better? There we go.
There you go.
If I plug in 1, 1 plus 1 is
2.
2. 2 squared,
4.
but it's negative, so -4.
-6.
-4 minus 2 is -6. Okay, so my graph, it shifted to the left and down, so probably somewhere over here should be my vertex.
Yeah.
It's facing down, and it has a normal shape. So if it doesn't face down, you know you did your points wrong. Okay, so let's see. -3, -6, -2, -3, -1, -2. Okay, so it shifted to the left and down. It's upside down. There's no change to the shape. But being able to identify the key features will really help you see that you graphed it right, because where you will mess up is your table of values. Because for whatever reason, our basic operation skills go out the window sometimes. So like our adding, subtracting, multiplying, we have issues with. Okay, so what I would like you to do is complete the 3 on the back with your group, or by yourself, I guess, if you want to. And then I'll come back in a few minutes. All right, number 5. The orientation is down. The shape is a compression. It translates right 1 and up 3. The vertex is at 1, 3, and my axis of symmetry is x equals 1. Did we get all those? Okay. Well, at least one person did.
Oh, yeah.
My point is 1, 3 for my vertex. 2 below are 0 and -1. 2 above are 2 and 3. Plug in whatever ones you want. So if I start with 0, 0 minus 1 is -1. -1 squared is 1. Then I multiply. -2 times 1 is -2. Plus 3 is 1. And when I plug in -1, you end up with -5 as your answer. So again, inside parentheses, exponents, multiply, add. Huh? PEMDAS, yes. It should face down. If it doesn't, you know you did something wrong, right? So -1, -1, 2, 3, 4, 5, 0, 1, 1, 3, 2, 1. And this one should also be skinnier than the parent function. And it definitely is a little narrower. I know it's a little hard to see on my screen. Okay, the last one was probably the hardest, and not in the sense that it was any harder, but you got a not as nice decimal. So first of all, the orientation is up. The shape is a stretch. It shifts to the left 1 and down 2. My vertex is at -1, -2, and my axis of symmetry is x equals -1. Center point, -1, -2, so 2 points below are -2 and -3, and then 0, 1. If you plug in 0, you end up with -1.3. So we can go through that real quick. Again, you have your calculator for a reason. So if I plug in 0, 0 plus 1 is? 1 squared is? Okay. So 2/3 times 1 is just 2/3. If you want to know what 2/3 is as a decimal, plug it into your calculator and then subtract 2, which is where you get -1.3 from. You're going to do the same thing for 1. So 1 plus 1 is 2. 2 squared is 4. And it's 4 times 2/3. And then minus 2, which gives you 0.67. So we're going to estimate them as closely as possible. So -3, 0.67 is more than 1/2 but less than 1, right? So -3 and then 0.67 is going to be about there. It doesn't have to be perfect. Let me zoom in a little bit so you can see. Okay. -2 and then -1.3, so that's less than 1/2, so it's going to be close to that 1 line. And then -1, -2. And just make sure when you graph the other side, they're in the same location. But your graph should look like that. It should face up. It should be a little bit of a stretch. Okay, I'm not necessarily looking at exactly where you place those points. Obviously, they need to be as accurate as possible. But when it comes to decimals, you are estimating a little bit. Any questions on that last one? Okay, so your quiz tomorrow covers, I'll give you an equation. You have to find the key features of the graph. And then you will be given equations where you have to create a table of values and graph them. Can you handle all that? No? You're going to have to, yeah.